Welcome to the Deep Dive, where we unpack concepts you thought you knew, revealing layers of complexity and insight that genuinely reshape your understanding. Today, we're plunging into a symbol so fundamental, so seemingly simple, that most of us dismiss it as, well, just nothing. We're talking about zero. We use it every day, we understand it as an absence, a placeholder, an empty set. But what if everything you thought you knew about nothing was actually just scratching the surface of something, incredibly profound and active?
It's a fascinating paradox, isn't it? Our common sense intuition often paints zero as this passive void, yet when you truly delve into its mathematical, physical, and even philosophical dimensions, it reveals itself as a dynamic, generative force. It's far more than just the number before one.
Absolutely. And that's precisely the mission for our deep dive today. We're going far beyond the basic arithmetic concept of zero to explore its, well, astonishing versatility. Our guiding document for this exploration, a work that has genuinely made me rethink fundamental aspects of reality, is The Manifold Nature of Zero, a taxonomy by Philip Randolph Lilien. This comprehensive source doesn't just challenge our everyday intuition, it offers a radically expanded, almost kaleidoscopic understanding of zero.
Indeed, Lillian's work posits that zero isn't a singular entity at all, but a vast and intricate zero group set. It's a meticulously structured taxonomy that reveals zero not as a passive absence, but as a dynamic, generative force that permeates the very foundations of mathematics, physics, and even philosophy. It's truly an architect of structure and possibility.
Our goal for you, then, in this deep dive, is to navigate this incredible framework. By the end, you'll gain a shortcut to being exceptionally well-informed about a concept often overlooked. You'll be armed with surprising facts and insights that will utterly reshape your perception of nothing. We're going to unpack just how diverse and powerfully active this single, unassuming symbol truly is, communicating its details comprehensively. So let's start by confronting that ingrained perception we all carry. For most of us, when we hear zero, our minds instantly go to absence, nothingness, or perhaps just a convenient starting point. It's the void, the lack, the empty space. It feels so straightforward, so singular. But Lillian's work really begs us to reconsider.
That's the crux of it. The central thesis Lillian lays out is that zero is not singular, but manifold. The source makes it abundantly clear that this isn't just a simple placeholder. It's a complex, evolving idea, a concept that is multiplied into numerous specialized forms as human thought has progressed. Each of these forms offers a subtly or sometimes radically different way to understand absence, balance, or potential.
Manifold. It's such an evocative word in this context. It implies so many different facets, so many layers to what we previously considered, a monolithic concept. Lillian illustrates how, throughout the history of thought, zero hasn't stayed static. Instead, it's branched out, diversified, evolving into these specialized forms, each one illuminating a distinct aspect of nothingness. It's like discovering that a single drop of water, when magnified, contains an entire universe of intricate structures.
Precisely. And to truly illustrate this multifaceted nature, Lillian introduces the zero group set. This comprehensive taxonomy is the intellectual backbone for our entire exploration today. It meticulously categorizes these different manifestations of zero across mathematics, physics, and philosophy, showcasing its broad applicability and astonishingly diverse interpretations. It's a grand unified theory of nothing, if you will.
And already you're probably thinking, wait, there's more than one zero. The answer, as we'll comprehensively unpack, is a resounding and fascinating yes. Each manifestation is more profound and surprising than the last. Let's really get into the nitty-gritty of these distinctions, starting with the bedrock, the forms that laid the foundation for much of our quantitative world.
Indeed. We'll begin our deep dive into the zero group set with what Lillian calls the oldest and most familiar zeros, the arithmetic and algebraic forms. These aren't just numbers. They primarily act as foundational elements within formal systems, defining the very structure of how we count, calculate, and define relationships between quantities. They're the silent architects of our quantitative reality.
Let's begin with the most familiar face, the one we encounter first in our mathematical journey, the arithmetic zero. Lillian defines this elegantly as the additive identity, representing absence in counting systems. But to a well-informed listener, what does it truly mean for zero to be an additive identity, and why was its invention such a game-changer beyond simply stating nothing is left?
That's a fantastic question, because its simplicity belies its profound impact. At its core, yes, it's the element that, when added to any number, leaves that number unchanged, like 5 plus 0 equals 5. But its true genius, its revolutionary power, lies in providing a universal neutral state. Imagine societies before a formalized zero. How do you account for a balance of trade? Or distinguish between no debt and an unknown amount of debt? Arithmetic 0 gave us that absolute starting point, a return to base, a quantifiable representation of emptiness. It not only anchors our entire system of addition and subtraction, but fundamentally enabled the concept of a number line extending into negative values. Without it, our mathematical universe would lack a crucial, unambiguous reference point for absolute emptiness, crippling our ability to track complex financial systems, scientific measurements, even logical operations. It's the silent architect that provides the crucial baseline for all modern accounting and quantitative thought.
That's a powerful way to frame it, a neutral state that unlocked so much. But 0 also wields a destructive or rather transformative power in our number systems, multiplicative 0. The source defines this as the annihilation principle, where any number multiplied by 0 vanishes. How does this function as a principle beyond just a simple arithmetic rule?
This is where 0 reveals its capacity as an ultimate reset button. When you multiply any value, no matter how astronomically large or, infinitesimally complex, by 0, the result is always 0. It fundamentally destroys or nullifies any value it interacts with through multiplication. Think of it less as a calculation and more as an operation of radical reduction. It doesn't just make things disappear, it transforms their very essence into the ground state of 0. In many systems, this annihilation property is critical. For instance, in physics, if a force component is 0, it effectively wipes out its contribution to an overall vector. It's a powerful tool for isolating variables and simplifying complex equations by removing specific influences. It highlights 0's active role in shaping outcomes.
Moving beyond basic operations, we encounter the algebraic 0, often referred to as roots. These are defined as the values of x for which a function fx equals 0. It's essentially about finding the exact conditions where a complex expression resolves into nothingness, a powerful concept that, despite its abstract definition, has very concrete applications in engineering, physics, and economics. How do we conceptualize this specific nothingness in practical terms?
Right, it's really about balance and finding critical points. When we set a function fx equal to 0, we're essentially asking, under what specific conditions or for what specific input values of x does this entire mathematical expression collapse to 0? Graphically, these are the points where a curve intersects the x-axis, the points where the function's output is 0. In engineering, finding the algebraic zeros of a function might tell you when a bridge structure is under 0 stress, or when an electrical circuit has no current flowing. In economics, it might pinpoint the break-even point where profit is 0. These zeros aren't just absences. They're precisely defined conditions of equilibrium, solution points, or critical thresholds that govern the behavior of a system. They are the hinges around which complex systems turn, defining their stability or transition states.
That helps make it much more concrete. But then we hit a truly mind-bending concept, zero divisors. The source defines these as elements in certain rings where two non-zero values multiply to yield 0. This just seems inherently counterintuitive. What's the biggest conceptual hurdle people face when trying to understand how two non-zero entities can produce 0? And what does that tell us about the flexibility of mathematical systems?
That's a fantastic question, because it directly challenges our most fundamental assumptions about multiplication. In the world of ordinary numbers, if you multiply two numbers and get 0, at least one of them must be 0. That's like a bedrock rule. But in abstract algebra, within certain mathematical systems called rings, which you can think of as number systems with their own unique, sometimes non-standard, rules for addition and multiplication, this isn't always the case. The conceptual hurdle is breaking free from the real number intuition. Take, for example, a clock where numbers wrap around. If we're doing arithmetic modulo 6, meaning we only care about the remainder when dividing by 6, then 2 times 3 equals 6, right? But 6 is equivalent to 0 on our modulo 6 clock. So 2 and 3 are both non-zero values within that system, yet their product is 0. It forces us to realize that even the fundamental nature of 0 can be redefined by the specific axioms and rules of the system it inhabits, demonstrating an astonishing flexibility in mathematical construction. It's a powerful reminder that our intuitive rules aren't universal.
That's a brilliant example, making the abstract truly tangible. And this idea of the neutral element for addition takes on an entirely different form when we move from simple numbers to quantities with both magnitude and direction. That brings us to the 0 vector, described as the neutral element of a vector space, the point of balance for linear addition. How does nothing manifest when we're talking about forces or movements?
Exactly. Our intuition for nothing usually thinks of an empty set, but with vectors, which represent quantities like velocity, force, or displacement, the 0 vector is far more dynamic than a mere absence. It's a vector with absolutely no magnitude and no specific direction, essentially. It's the ultimate standstill. Conceptually, It represents the origin of a coordinate system, the precise point of no displacement, no net force, or no change in position. If you add a zero vector to any other vector, that vector remains utterly unchanged, just as adding arithmetic 0 to a number leaves it as is. It signifies a state of perfect equilibrium, a foundational quietude from which all motion or forces are measured. It's the ultimate still point in a system that can be incredibly dynamic, providing the reference for no movement or no influence.
And finally, for this section, we dive into the incredibly abstract world of zeromorphism. The definition is, in category theory, the null map connecting objects without transmitting structure. Okay, category theory sounds incredibly dense, but can you give us a more vivid analogy to grasp this null map?
While category theory can seem intimidating, think of a zeromorphism as the ultimate null and void communication channel between two complex systems. Imagine you have a vibrant, intricate library, that's our first mathematical object, filled with information, and you want to send information to a plain, empty room, our second object's zero object. A zeromorphism is the specific kind of mapping or function that takes every single book, every piece of information from that library, and transforms it into, well, nothing relevant in the empty room. It establishes a connection, but it explicitly communicates no meaningful structure or detail. It's a mapping that wipes the slate clean, ensuring whatever complex input you have, the output is always the neutral or nothing equivalent in the target system. It's a formal way of saying no meaningful information passed through, essential for defining structural relationships in abstract mathematics without necessarily conveying content.
So these arithmetic and algebraic forms aren't just mathematical curiosities. They are critical for defining structure and operations in various mathematical fields, as the source puts it. It showcases zero's foundational, even revolutionary role. It's amazing how many different nothings we've already found just in the basics of math, each one performing a distinct function.
And we're truly just getting started. As we move into the realm of analysis and geometry, zero takes on more dynamic roles, often signaling limits, boundaries, or baselines. These are not static nothings, but active markers, critical thresholds, and conceptual vanishing points in continuous systems, guiding our understanding of change and scale.
That's a great distinction. Let's delve into limit zero. This is defined as values approached asymptotically, signifying vanishing magnitudes. This brings us straight into calculus, doesn't it? How does this idea of getting infinitely close to zero without necessarily reaching it provide critical insights?
Absolutely. Limit zero is a cornerstone of calculus. It's not about zero as a fixed point, but as a conceptual target. Think about a function where, as you increase the input value towards infinity, the output value gets progressively smaller, say 1 divided by x. As s gets larger and larger, 1x gets closer and closer to 0, but it never actually becomes 0. That's getting infinitely close to 0 in asymptotic approach. It's a conceptual boundary that defines the behavior of a system at its extremes, signaling a magnitude that is effectively vanishing. It's crucial for understanding rates of change, instantaneous velocities, and the long-term behavior of systems, helping us understand trends and the true essence of diminishing quantities. It's a dynamic nothingness, the ultimate vanishing point.
Then there's measure zero, defined as sets with no size in a continuous space, crucial in probability and integration. How can a set have no size, and why is that important in complex systems?
This is a concept vital in advanced mathematics, particularly in probability theory and the study of integrals, where we deal with continuous quantities rather than discrete counts. Imagine a single point on a one-dimensional line. Does that point have any length? No, it's infinitesimally small. Or consider a perfectly thin line drawn on a two-dimensional plane. Does that line have any area? Again, no. These are examples of sets of measure zero. They exist, you can identify them, but they don't contribute to the overall size or volume of the continuous space they inhabit. This implies an infinite divisibility, where specific points or lines are negligible in the grand scheme of a continuum. It's crucial for distinguishing between what's statistically significant and what's effectively negligible in continuous systems. For instance, understanding that the probability of landing on any exact point on a dartboard is 0, even though you will land somewhere. It's a way of formalizing what truly doesn't matter in continuous measurements.
That's fascinating, a presence without contributing to total quantity, highlighting the nuances of nothingness in continuous systems. Next, zero crossing. This is described as points where a curve intersects the baseline, marking balance and oscillations. What kind of insights can this specific nothing provide in fields like engineering or music?
This is a very intuitive and practically important concept, especially in fields like signal processing, electrical engineering, or even the analysis of sound waves. Imagine a sound wave, an electrical signal, or even the swing of a pendulum. These are typically represented by a curve that oscillates above and below a central equilibrium line, often the x-axis or a zero baseline. A zero crossing is precisely the moment that curve passes through that equilibrium point, the instant the positive value transitions to a negative, or vice versa. It signifies a change in direction, a moment of perfect balance, or a specific phase in a cycle. In music, zero crossings are vital for understanding frequency, timbre, and even for digital audio compression. In medical imaging, they can help identify specific features in waveforms. It's where the positive and negative values perfectly cancel out, providing a crucial marker for understanding dynamic behavior.
And then the very familiar coordinate origin. This is the geometric zero, the point 0, 0, 0 from which position is defined. We use this constantly, but what's its deeper significance as a zero?
The coordinate origin, typically denoted as 0, 0 in 2 dimensions or 0, 0 in 3, is the absolute reference point in any coordinate system. It's not just a convenient starting point, it's the spatial manifestation of nothingness in terms of displacement. It's where everything begins spatially, the anchor point from which all other positions are measured. Every point, every vector, every geometric transformation is defined relative to this zero. It defines the 0 point of our spatial understanding, the center of our observational universe, for lack of a better term, providing the fundamental baseline for mapping and navigating space. Without it, our ability to precisely locate and describe objects in space would just, well, collapse.
Finally, in this category, we have topological zero. This is the trivial or degenerate base point in homotopy or mapping structures. Okay, topology can be quite abstract. How does zero function in this context?
It can be. In topology, which studies the properties of space that are preserved under continuous deformations, essentially, stretching, bending, or twisting, without tearing or gluing a topological zero, refers to a specific type of reference point. It could be a trivial object, like a single point in a complex space, that acts as a base for defining more intricate structures, or a degenerate element where a structure has collapsed to its simplest form. Think of it as a point that has no intrinsic structure itself, but acts as a focal point or a foundational element for understanding how complex shapes relate to each other. For example, in homotopy, which studies how paths or surfaces can be continuously deformed into one another, a base point, often a topological zero, anchors these deformations. Here, zero helps to define transitions, scales, and reference points in continuous or spatial contexts, highlighting its role in dynamic systems by providing a stable, structureless reference.
So in these analytic and geometric contexts, zero isn't just about absence, but actively helps to define transitions, scales, and reference points in continuous or spatial contexts, which truly brings out its dynamic, almost operational nature. It's fascinating how nothing becomes so crucial for defining something.
Indeed. Now we shift gears dramatically. In physics, zero transcends abstraction to become an ontological concept, describing fundamental states or conditions of existence. This is where nothing itself becomes highly structured, profoundly influential on the very fabric of reality, shaping our understanding of the universe itself.
Starting with one we've all heard of, absolute zero, 0K. This is the lowest possible thermodynamic temperature where molecular motion halts. How does this physical zero challenge our everyday experience of cold and energy?
Absolute zero, 0 Kelvin, or approximately negative 273.15 degrees Celsius, isn't merely very cold, it represents a fundamental physical limit. It's the point where the kinetic energy of particles is minimized to its absolute lowest possible state, according to classical thermodynamics. Atomic motion, in the classical sense, would essentially cease. While we can approach it incredibly closely in specialized laboratories, achieving it perfectly is considered an unreachable theoretical limit due to quantum mechanical effects. This zero isn't just a number, it's a profound physical boundary, defining the ultimate energetic nothingness and providing a baseline for all thermodynamic processes. It shows us that even the absence of heat is a deeply structured and significant physical state.
And then something that completely flips our intuition about nothing. 0-point energy. This is the irreducible energy of quantum fields, the vacuum zero. The source explicitly states, this highlights that even a vacuum is not truly empty. How can nothing be full of energy? This is truly mind-bending.
This is one of the most counterintuitive and profound concepts in quantum mechanics, directly challenging our classical understanding of a vacuum. According to quantum field theory, even a perfect vacuum, seemingly devoid of matter and energy, is not truly empty and quiescent. Instead, it possesses a minimum, irreducible amount of energy. This is due to constant spontaneous quantum fluctuations. Particles and antiparticles are constantly popping into and out of existence for fleeting moments, even in empty space. This vacuum zero energy is a fundamental inherent property of the universe itself. A classic demonstration is the Casimir effect, where two uncharged parallel metal plates placed very close together in a vacuum experience an attractive force. Scientists attribute this to the subtle pressure differences from these quantum fluctuations outside versus inside the plates. It fundamentally redefines our understanding of what nothing truly means, at the most microscopic level, a dynamic energetic void rather than a passive emptiness.
That's incredible. A dynamic, energetic nothingness bustling with activity. Next, the zero mass limit. This is the case of particles like photons or neutrinos approaching pure coherence without rest mass. Right? How does this zero in terms of mass dictate the behavior of fundamental particles and their role in the universe?
This refers to fundamental particles that either have no rest mass whatsoever, such as photons, the quanta of light, or those with incredibly tiny, almost negligible rest mass, like neutrinos. The concept of rest mass refers to the mass of a particle when it is at rest. If a particle has zero rest mass, it can only exist by traveling at the speed of light in a vacuum. This is why photons are always observed to move at light speed. For neutrinos, their minuscule non-zero rest mass, only discovered relatively recently, means they travel incredibly close to the speed of light but can, theoretically, be brought to rest. Their existence at or near this zero mass limit allows them to behave in unique ways, often exhibiting wave-particle duality and playing critical roles in how energy and information propagate throughout the universe. They represent a fundamental state of pure energy or near-pure energy in motion, where the nothingness of mass allows for maximum speed and fundamental interactions.
And then the terrifying zero radius. This is the singularity condition of black holes where spatial extent collapses. This sounds like the ultimate concentration of something into nothing.
This takes us to the extreme limits of general relativity. At the very heart of a black hole, the theory predicts that all the immense mass of the collapsed star concentrates to an infinitely dense point with zero radius, a singularity. It's a point where our current understanding of physics breaks down, where space and time warp to an unimaginable degree. Here, nothing in terms of spatial extent becomes everything in terms of density. It's a conceptual zero point for physical dimensions, a point of extreme compression where the very fabric of space-time is thought to be torn. While still a theoretical construct, it represents a profound limit to our physical models, a nothing that challenges our geometric and spatial intuitions at the most extreme level.
Finally, in this category, we have cosmic zero. This is defined as the pre-Big Bang void or baseline from which cosmogenesis emerges. This really stretches the imagination, thinking about a nothing that preceded everything.
This takes us to the grandest scale of all, the origin of the universe itself. Cosmic zero refers to the theoretical state, or even non-state, that existed before the Big Bang the moment our universe is believed to have begun. It's the conceptual nothing from which everything space, time, matter, energy, all of existence emerged. While the exact nature of this pre-Big Bang state is still a subject of intense scientific and philosophical debate, it serves as the ultimate conceptual origin point for existence itself. It's the baseline from which all of cosmogenesis, the birth of our universe, began. It's a nothing so profound that it harbored the potential for all of reality.
So these examples truly demonstrate that even nothing in physics is dynamic, structured, and often paradoxically full. It's a far cry from an empty placeholder. It's clear that zero isn't just about observation, it's active. And the source goes even further, introducing what it calls the coherence framework, which gives zero an even more explicit generative role.
That's right. Lilien's coherence framework is a unique contribution, presenting 7 distinct ontological operators for zero, explicitly emphasizing its active generative role. This framework positions zero not as a passive absence, but as a dynamic force for creating order, structure, and potential. It redefines nothingness as a fertile void.
So it's not just where things are zero, but how zero actively contributes to formation and structure. Let's break down these 7 operators, starting again with a familiar concept. Arithmetic zero, which in this framework is identified as the incoherence baseline. What does that mean in a generative sense?
Here, arithmetic zero is recontextualized as the foundational state of non-coherence, or total nullity. Imagine a system where there's no pattern, no order, no quantity. That's the incoherence baseline. From this absolute state of nothing, structure and coherence can emerge. It's the blank slate or the empty stage before any actors arrive, representing the ultimate lack of organization from which all order must spring. It's the prerequisite for building complexity.
Next, factorial zero, which the framework assigns the role of coherence identity. This is interesting because zero is mathematically defined as 1, not 0. How can zero define identity here?
Exactly. This is a crucial distinction and a profound insight. In combinatorial mathematics, 0, 0, 1. This isn't nothing in the sense of absence. Instead, it defines a baseline of identity or unity. It represents the single, unique way to arrange 0 items, which is effectively to do nothing at all. This single way establishes a coherent starting point for counting permutations and combinations, a fundamental statement of unity or inherent order from which more complex structures can be built. It's the simplest possible act of coherence, a fundamental self-contained unit.
Then we have exponential zero, zero Eric's, given the role of seed emergence. This is another one that can be debated mathematically, sometimes defined as 1, sometimes indeterminate. How does this mathematical ambiguity allow it to represent seed emergence?
Precisely. While often defined as 1 in many contexts for consistency and utility, its indeterminate nature in certain mathematical fields makes it a fascinating 0 within this framework. Here, it symbolizes a point from which something can emerge or be generated. Think of it as a singular, concentrated point of potential. It's like a seed of potential, a fundamental unit of initial creation from which complexity and emergent properties can sprout. It's the mathematical symbol for the point where something can begin, embodying a profound generative capacity.
Next up is zeta naught, designated as absolute coherence. This hints at a deeper, fundamental level of order. What might this absolute coherence imply?
While not explicitly detailed in the provided source material beyond its role, zeta naught suggests a profound and fundamental level of intrinsic coherence. It implies a universal baseline of order, a pristine state of inherent organization that exists independently of any external influences. It's almost like a perfect, unadulterated 0 of inherent order, a kind of primal, self-sustaining harmony from which other forms of coherence or structure might derive. It represents the ultimate, pure state of organized nothingness.
Then there's tower zero, zero Orion, representing recursive potential. This refers to tetration, where you have 0 to the power of 0 to the power of 0, and so on. An incredibly powerful operation. How does this abstract concept embody recursive potential?
This is an extremely abstract concept drawn from hyperoperations, specifically tetration, which is repeated exponentiation. The idea of 0 to the power of 0 to the power of 0, repeated in times, suggests an infinite self-referential potential. It represents the inherent capacity for a system to recursively generate immense complexity and structure from a foundational 0 state. It embodies the concept of boundless generative power locked within nothingness, demonstrating how a simple 0 can, through recursive operations, unlock an explosion of potential. It's the mathematical expression of something from nothing, through infinite self-replication of a foundational state.
The sixth ontological operator is dimensional zero, described as projection loss. What does losing spatial extent to a core essence mean in this context?
Dimensional zero implies the act of reducing or collapsing dimensions to a point or losing spatial extent. Imagine collapsing a complex three-dimensional object down to a two-dimensional plane, then further to a one-dimensional line, and finally to a single zero-dimensional point. This process signifies simplifying to a core essence, or losing complex spatial projection to arrive at a fundamental minimal zero state. It's about distillation, reducing all complexity to its most basic essential form, a nothingness that retains the memory or potential of higher dimensions, yet presents as a singular fundamental point.
And finally, symmetry zero, the balance operator. How does zero act as a point of perfect equilibrium?
This positions zero as the point of perfect symmetry or equilibrium, where opposing forces, elements, or values perfectly cancel each other out, resulting in a state of harmonious balance. Think of a perfectly balanced scale, where the net force is zero, or a perfectly symmetrical object where every part has an equal and opposite counterpart. In physics, it might represent a stable system where all forces are in perfect counterpoise. In mathematics, it could be the midpoint of a distribution where positive and negative deviations perfectly cancel. It's the ultimate expression of equilibrium, a point of resolution where all tensions are nullified, revealing a profound and active form of nothingness as perfect balance.
So these 7 classes are genuinely positioning zero as not a passive absence, but an active generator of coherence, resonance, and reduction. It's incredible to think of zero as doing so much fundamental work in structuring our reality.
And the profound nature of zero isn't a modern discovery, confined to mathematics and physics. Long before its mathematical formalization, Across philosophical and spiritual traditions, zero has long been interpreted as a foundational, generative emptiness. This demonstrates humanity's deep, long-standing intuition about its profound active nature.
Let's start with shunyata from Buddhism. This is defined as emptiness as interdependent potential. This sounds like a philosophical counterpart to the zero-point energy we discussed earlier.
It's an excellent parallel, drawing from ancient wisdom. Shunyata, often translated as emptiness, is not a nihilistic void, a mere nothingness. Instead, it signifies the profound truth of a lack of inherent independent existence for all phenomena. Nothing exists in isolation. Everything arises interdependently, constantly changing and interacting. Therefore, this emptiness is not a void, but rather the very condition that allows for all phenomena to arise and change. It's the potential for everything. It's a dynamic and fertile ground for existence, a nothing that allows for all possibilities and connections. It's a non-dualistic absence that is the source of all being.
Then, from Kabbalah, we have Ein Sof. This is the infinite nothing that precedes creation. How does this mystical neuro articulate the origin of the cosmos?
In Kabbalistic mysticism, the Ein Sof refers to the unmanifest, unknowable divine essence that existed before any creation. It is an infinite nothing, a boundless void that contains all potential and from which everything in the universe eventually emerged through a process of emanation. It is absolute abstraction, beyond human comprehension, yet it is the ultimate source of all being, the primordial zero of existence. It represents the ultimate unknowable, the creative emptiness that harbors infinite possibility before anything is manifest.
And we also see similar concepts in ancient thought. The Greek void Taoist Wu are described as absence not as negation, but as primal ground. What do these ancient traditions teach us about the active role of nothing?
That's right. In ancient Greek cosmology, the concept of chaos or void was often seen not as an arbitrary mess, but as the formless, undifferentiated state that existed before the cosmos was ordered and created. It was the raw, unformed potential from which the universe emerged. Similarly, in Taoism, Wu, often translated as non-being or nothingness, is considered the metaphysical source of you-being. The famous line from the Tao Te Ching, "The 10,000 things are born of being, being is born of non-being," beautifully encapsulates this. Both traditions view absence not as a mere negation or lack, but as the fertile primal origin from which all existence and order spring forth. It's the creative ground from which reality manifests, the fundamental zero that provides the space and potential for everything to come into being.
And then the overarching concept of mystical zero. This is the paradox of fullness and nothingness, where ultimate reality is described through negation. How does this nothing reveal the everything?
Many mystical traditions across various cultures and beliefs share this common thread. They describe ultimate reality, the divine or absolute truth, not by what it is in positive definable attributes, but by what it is not. This emphasis on negation, what is often called apophatic theology, highlights its transcendence, its inability to be confined by human language, categories, or conceptualization. It's a profound paradox where the ultimate nothing is simultaneously the ultimate everything, a fullness so immense that it can only be approached by shedding all preconceived notions of being. It's the silent, ineffable ground of all existence, a zero that encapsulates infinite potential by being beyond all specific forms.
It's truly astounding that these traditions anticipate the ontological richness of zero long before its mathematical formalization, showing just how deeply humanity has intuited its profound generative nature across millennia. It brings us full circle, connecting ancient wisdom with modern scientific and mathematical inquiry, showing a continuity of profound thought.
It really does.
Yeah.
It underscored how certain fundamental truths about reality are perceived and understood in different cultural and intellectual contexts, yet often point to the same underlying principles.
So let's bring all these diverse forms of zero together, from the most basic arithmetic to the deepest philosophical and mystical insights. We've taken quite a journey through its manifold nature, comprehensively exploring its roles, haven't we?
We have. And the crucial overarching theme that emerges, the profound takeaway from Lilien's The Manifold Nature of Zero, a taxonomy, is this: zero is not nothing. It is the most fertile operator of all, holding within itself the key to coherence, resonance, and emergence.
That's such a powerful statement. It's not passive, it's profoundly active. It's not empty, it's saturated with potential. Whether we're looking at it as an identity in our number systems, an annihilator that radically resets values, a baseline for measurement, a crucial boundary in continuous functions, a fundamental threshold in physical states, a profound void from which existence emerges, or an active generative operator within the coherence framework.
Zero plays a fundamental, indispensable role in defining and creating reality across various domains of thought. It's an architect of structure, a catalyst for transformation, and a silent, yet incredibly powerful, partner in the very fabric of existence. It provides the canvas for creation, the ground state for all complexity.
This isn't just a fascinating detail for mathematicians or philosophers. It's a genuine paradigm shift in understanding a concept we all use every single day. It profoundly demonstrates how even seemingly simple ideas, when examined closely through the lens of diverse disciplines and with a comprehensive approach, can unlock some of the most profound insights into the nature of existence itself. It shows the incredible depth, structure, and generative power that can reside within nothing.
And it truly challenges us to look beyond the surface of what we think we know.
Absolutely. So as we wrap up this deep dive, consider this expanded understanding of zero you've just explored. It's a dynamic, structured, and fundamentally generative force, far removed from mere nothing. The next time you encounter a zero, whether it's in your bark account, on a graph, in a scientific equation, or reflected in a philosophical text, will you merely see an abscess, a lack? Or will you recognize the dynamic, fertile potential lying within that single, powerful symbol?
Will you see a void, or will you perceive the wellspring of coherence, emergence, and possibility?
We hope you'll recognize the profound possibility and the active role this powerful symbol plays in shaping everything around us. Keep an eye out for how nothing around you might actually be a source of incredible potential, mirroring the manifold nature of zero. Thank you for diving deep with us.